In this video, I will solve a optics question which involves lens and mirror combination. First, I will discuss some basics. This is a mirror. This is a concave mirror because from the object side or the shiny side, it looks like a cave. So the object is here. Usually, the image will form on the left side, and we have to choose the direction. Origin is at the location of the mirror, and the positive direction should coincide with the direction of the incident light. So from the object, this is the incident light direction, which is towards right. So the right direction is positive. So the mirror formula is 1 by u plus 1 by e equal to 1 by f. Mirror the form. And I'll fix the sign in the next step. U is negative because it's on the left side. V is also negative usually. And focal length is negative because to get the focal length, we have to send a parallel beam of light and it converge here at the focal point. So focal length or the focus on the left side. So focal length is negative. So all are negative usually. So I'll put a minus sign to make these terms positive. And I can cancel the negative sign to get this formula. Then I remove the formula. I'll get the terms and then I'll fix the sign. Plane mirror, we know object kept at a distance, the image from the other side, and it's a virtual image at the same distance, and the magnification is 1. So V equal to U, but again, positive direction has to be chosen. So its direction should coincide with the direction of incident light. It's towards right. So U is negative and V is positive according to its convention. So to make this term positive, I have put a minus sign here. Another way to get this formula is concave mirror. In the limiting case, it's a plane mirror because concave mirror is basically a spherical shell and you cut part of it. So if you take a concave mirror like this, where the radius of curvature is small, so the focal length will be somewhere here. So somewhat less curved concave mirror, the focal length will be a little bit far away. So in the limiting case, the concave mirror will look like this. It will become flat and the focal length will be at infinity. So in this concave mirror formula, if you put f equal to infinity, you should get this one. So you put f equal to infinity, this term is 0. So take u on the right side and take the reciprocal because you get v equal to minus u. So this, another way of getting this formula, v equal to minus u for a plane mirror. So this is basic of mirror. Similarly, lens, I'll discuss some basics. This is a convex lens, objects from the left side. Okay, so the incident ray will be towards right, so the positive direction is towards right. The image position is the origin. Okay, so usually the image will form the right side. So the formula is 1 by u plus 1 by u equal to 1 by f, and I'll fix the sign in the second step. U is negative, V is on the right side, V is positive, and focal is also positive because to get the focal length, that is in parallel beam of light, you get focused here. So focal is on the focus on the right side, so focal is positive. So when U is negative, so to make that term positive, put the minus sign here. This is where I remove this formula. Okay, so in one special case, if I keep the object at the focal length, so this is the focal length, F, and if you keep the object here, then U is minus F because focal length is positive and U should be negative. So U is minus F. If you put U equal to minus F here, this term and this term are same. So that means this term should be 0. That means V is infinite. So it will produce V infinite means light ray will go like this. So it's a parallel beam of refracted rays. So when the object is at focal length, the light will go like this. It will go like this and come out parallel with the principal axis. Go like this, and the other side will come parallel to the principal axis. Another ray like this will come out parallel to the principal axis. So the only way to produce parallel beam of refracted rays is to have the object at the focal point. That also we'll see from the formula because V equal to minus F means 1 by V is 0, so V should be infinite. So with this basic, you can solve this question. This is the question. An object is placed at 2f of a convex lens of focal length 25 centimeter. This f is focal length only, so 2f is 50 centimeters. The plane mirror is kept in such a distance from the lens on the other side that the rays reflect from the mirror while passing through the lens are parallel to the principal axis. So the light is going like this. After passing through the lens, will form an image. Suppose this plane mirror was not there, we'll go and form an image with this I1. But since this plane mirror is blocking it, this one going here will get reflected here and come to this focal point, because after it gets refracted for the second time, the ray is coming out parallel. That is the condition. So since this ray is parallel to this one, the image formed by this plane mirror should be at the focal point of this lens. So we can consider this as 3 steps. First step is to get refracted by this lens. So the image is forming at this I1. Suppose this plane mirror was not there. But since this plane mirror is blocking it, you will get reflected, and the image of this thing will form at this focal point of this lens. After crossing this focal point, it will come out parallel. So first step is to get refracted by the lens. Second step is to get reflected by the mirror. Third step is to get refracted by the lens second time. So the first image I1 is by the lens. Second image I2 is by the mirror. The third image I3 will be at infinite, because it's a parallel beam of rays, parallel beam of light, so it will converge at infinity. So the image is at infinite. So I3 is at infinity. Focal length is given f, that's f, and u is 2f. So from this I can find the v of the first image using the lens formula. 1 by equal to 1 by e equal to 1 by f, and there is a negative sign with u because u is negative, these two are positive. So u is 2f with a minus sign, because f is positive for a convex lens. Most important thing is to get the sign right, otherwise the answer will be wrong. So u is focal length is positive for a convex lens. So since u should be negative in this particular case, it should be minus 2f. So u is minus 2f. So if you put that in correctly, it will be 1 by 2. The first term will be 1 by 2f. So from this I get v as 2f. So this distance v of this I1 from this lens is 2f. But from the plane mirror, let it be at a distance x, because we don't know. We have to find out that. And the plane mirror property is v equal to u on the other side. So the image, this push where the image is formed, this I2 is formed, it's at distance x from this plane mirror. And this I2 should be at a focal length of this convex lens, because the refracted rays coming out at the third step is parallel to this principal axis. So that means this object, which is I2, image after the second stage, should be at the focal length. So this distance is f. So this distance d is focal length f plus x, and this distance of I1 from this lens is f plus 2x. That is same as 2f, because that we have found out here. Okay, so that means f plus 2x is 2f. These are basic summary which I already explained. So f plus 2x is 2f. This is f, this is x, this is x. So this total distance is f plus 2x. That should match with 2f. So from this I get x as f by 2. So once I get x, I can find this d, which is f plus x. This is 3 by 2, f, which is 1.5 times f. So 1 times f is 25, and half of f is 12.5. So 31.5 centimeters, because everything is given in centimeters. So correct option is option D.